This is Vodcast 5C. In this Vodcast, we're going to talk about acids and how to name acid compounds. So first thing, for our purposes, acids always have hydrogen. This is our cation. This is what our formula starts with. It always starts with an H. We said before that acids taste sour, they turn blue litmus paper red, they have low pH, below neutral 7, and they react with bases to form salts. Acids are very similar to ionic compounds. They dissociate. They break up into their cations. Again, in this case, if it's an H, it's an acid, or if it's an acid, it's always going to be a hydrogen as your cation, and whatever your anion is when you put them in water. The dissociation is slightly different. It can vary from 0 to 100%. We saw in the lab that we did, the 0% are generally the weaker acids, and the 100% dissociation are usually the stronger acids. The charges are going to balance just like ionic compounds when we write the formulas. However many positive charges we have to have that many negative charges. So here we go. There are 3 different rules for naming acids. First things first, though, everything has to start with hydrogen. When you see that hydrogen, you know your rules are slightly going to have to change. Since the cation is always hydrogen, we're really only naming the anion. So if you have an 8, a phosphate, a sulfate, a nitrate coming from your table, from your periodic folder, your polyatomic list, anything 8 changes to ic acid. So here's HNO3. NO3 is nitrate. Nitrate changes to nitric acid. Because it starts with an H, it always has to end in acid. Because we know it starts with a cation H, it's always going to be an acid. So 8 changes to ic. You ate icky acid. If it ends in ite, ites again are from your list, from your polyatomic list, phosphite, sulfite, nitrite, NO2 1- is nitrite. Nitrite changes to nitrous. Ite changes to us. Nitrite changes to nitrous. Sulfite would change to sulfurous. Phosphite would change to phosphorus acid. Ite changes to us. Itis. We have 8 to ic, 8ic, and ite to us, itis. And the last one, if it ends in ide, there are a couple on your polyatomic list, but mostly these come from the ions that are on the periodic table. Any anion that you pull off the periodic table, it ends in ide. So here's the example. N with a 3- charge is just nitride. Nitride changes to hydronitric acid. Ide changes to hydroic acid. So the one that we use a lot in the lab, HCl, is chloride, which is why its name is hydrochloric acid. So remember these 3 things. 8 changes to ic, 8ic. Ite changes to us, itis, 8ic, itis. And ide changes to hydroic acid. That's how the acid names are going to be different. I'll do 1 and 5 and 10 with you on this list. H2SO4 starts with an H. All of these starts with an H or end in acid, so we know they're all going to be acids. When it starts with an H, all I have to do is name the anion. Looking on your list, SO4 is sulfate. What are my rules? 8 goes to ic. ite, us. 8-ic, ite, us. That leaves ide, hydroic. Acid naming rules. So, when it ends in ate, like sulfate, I change that to sulfate goes to sulfuric acid. 8 goes to ic. Number 5. Number 5 I know is also an acid. It has an H. I name it using the anion only, MnO4. If I look at my list for MnO4, it's permanganate, MnO4. Again, I end in 8, so 8 changes to ic, so it would be permanganic. Why did my pen stop? Permanganic acid. And finally, number 10. How do I do this? Now we're going backwards. Now I have to look at sulfurous acid. Us is the second one. Us goes back to ite. So I need sulfite. Looking on my list. Sulfite is SO3 with a 2 negative charge. The charge on your anion, in this case, tells you exactly how many hydrogens you have to have, since hydrogen only has a 1 plus charge itself. So if I have a 2 minus charge, that means I need 2 hydrogens to balance out with 1 SO3 group. H2SO3 is sulfurous acid. Remember up here was sulfuric acid, and that was sulfate because there was an SO4. So slight differences. Keep practicing. Do the rest of these, and we'll check them in class.